Hello everyone, this is Emmanuel and I'm back with another tutorial about AI agents. Today we are going to be building an AI agent called Onchain AI Agent with CrewAI. And what is an Onchain AI Agent? An Onchain AI Agent is an AI agent that can help you in making decisions as a person who buys and sells crypto, whether it's Ethereum, Binance, Bitcoin. It can help you in making decisions. All you just have to do is just to put in your crypto address or your wallet address, choose the network that you want to get information about from here, and run analysis. Also, you have to put your API keys. Today we're going to be using Zapper API and OpenRouter API key, and all you just have to do is click on run. And also we're also going to deploy this with render. As you can see my URL, there is render in it, so we're going to be deploying this with render. So let's hop on into our code and see how we can run this AI agent, or see how we can build this AI agent. And I'll also give you the link in the description below. Please follow me, subscribe, and like this video so that other people can see it. So let's jump into our code. Thank you. Okay, right now we are on the Zapper protocol documentation. Or you have to go, if you want to see this page or access this page, you just have to go to protocol.zapper.xyz/docs/API. I'll leave the link in the description of this video, and you can just go through their documentation. It says over here, access powerful on-chain data created by Zapper protocol with GraphQL API. So you can go here and see what it's about. If you want to get your API key, all you have to do is click on get API key, then click here, get your API key, and it will take you to this, and you can copy your API key from here. So this is where you can get your API key. You get a free 5,000 credit balance from Zapper free when you sign up. So all you have to do is sign up with your email, and you get a free 5,000 credit balance. Okay, so you can see I've used some of my credit balance, and yeah, it's simple to set up like that. So let's go to our IDE and see how we set up this AI agent. So to start with CrewAI, or to start creating this AI agents, all you have to do is first of all create your use the CrewAI CLI to create your project structure, and I'll show you how to do it right now. So to do it, you have to use CrewAI has two types. Either you're using Flow or you're using the normal Crew. So right here we are using the normal Crew, and as you can see, my project name is Onchain Agents. So you have to write CrewAI create Crew Onchain Agents, and you click on enter. You choose your let me just show you right now. You click on enter right here. It's very, very easy. You have to wait a little bit. Hold on. Yeah, so you choose your LLM provider. For me, I'll be using let us choose Anthropic, because this is just an example. Then you choose your model you want to use. I'll choose one, and you put your API key. You can just put any API key and click on enter. When you've done that, you can see it over here. Which one is it? Yeah, so it's this one right here. As you can see, my project structure has been automatically created for me. So what you have to do right now is to create your virtual environment, and to do that you have to put in this command line in your terminal. So you have to put in this command line, Python /m vmv.vmv, and click on enter. Or first of all, before we do that, we have to cd into the directory, and the name of our own directory is Onchain Agents, Onchain_agents. When you've done that, then you can create your virtual environment. Yeah, so you have to activate the virtual environment with this command line. So when you've done that, then we have to start looking at our code. Yeah, so we have to start looking at our code. So right here, I've written our code for us. I've written the code for us, which you can see right here. This is one of our tools. So let's dive into our codes. So in this our project, we have two folders. One is where we create all our agents, excuse me, agentic flow with CrewAI, and the second one is the folder for our UI. We are using Streamlits. So let's dive into the code. So right now we are starting with the agent.yaml file. We are starting with the agent.yaml file, and we have 3 agents if I'm not mistaken. So we have the portfolio intelligence analyst, we have the transaction pattern specialist, and we have the cross-chain investment strategist. So the portfolio investment intelligence analyst, you can see the role. The role is a senior blockchain portfolio analyst specializing in multi-chain assets evaluation, risk assessment, and performance attribution with advanced on-chain data and interpretation capabilities. You can see the goal, you can see the backstory, so we don't want to dwell so much on that. Our second agent is the transaction pattern specialist. You can see the role, senior on-chain behavior analyst specializing in transaction sequence pattern recognition, protocol interaction mapping, and anomaly detection across EVM compatible blockchains. So yeah, I don't really know the full meaning of EVM. I'm not into crypto and all that. So I don't really know the meaning of EVM. So we have the core and we have the backstory. And our third agent is the cross-chain investment strategist. You can see the role, which is lead cross-chain investments architecture, specializing in a multi-network capital efficiency optimization, inter-ecosystem arbitrage modeling, and blockchain-specific alpha generation strategies. So yeah, so this is the role. You can see the goal and you can see the backstory. So let's move on to the tax. Our tax over here. So we have 4 tags if I am not mistaken. 4 tags if I'm not mistaken. We have the portfolio analysis tags. You can see the description. With CrewAI you have to have a very good description of all your tags. You can see the expected outputs. And it's assigned to the portfolio intelligence analyst. So we have the transaction pattern analyst. You can see the description. I'll leave the link to this code in the description below, and also please follow and like if you're enjoying it, or if you're enjoying my content. It really helped me much. So we have the description as I was saying, and we have the expected outputs. We also have the agent that it is assigned to, which is the transaction pattern specialist. Then we have our third task, which is investment opportunity identification. We have the description. We have the expected outputs, and we have the agent that is assigned to, which is the cross-chain investment strategist. And we have the fourth task, which is the comprehensive intelligence reports. We have the description. We have the expected outputs, and we have the agent that it's assigned to, and we also have context. So this task would depend on the output from the first 3 tasks to make up its own outputs. As you can see, let's go back to the description. It says create a comprehensive integrated intelligence report for wallets, for the wallet address that you put, that synthesizes all previous analysis into a cohesive strategic document with actionable recommendation. Okay, this is the final culminating task that delivers maximum value to the wallet owner. Okay, so yeah, so
this is their last task. So you can see he has to create a comprehensive intelligence reports, and he needs the output from the past or from the first 3 tasks. So right now we are in our crew.py file, and this is where we assemble all the tasks and all the tasks and agents together with our tools. But first of all, before we talk about the crew.py file, let's go to our tools.
So we are in our tool section right now, and we'll be looking at our tool right now. We are importing all what we need to import. We are importing OS requests. If you look at the Zapper protocol API documents, you see that you need to import requests. Excuse me. You need to import requests for your tool to work. We're also importing JSON, and typing from. We're also importing date, any optional from typing. Yeah, so we're defining our class, which is super base. The base class for this is Zapper API tool with common functionality. We're defining our GraphQL API endpoints. We're also defining our network ID mapping. That is the network name to chain ID. We're also getting our API key. If you check the env file, you'll see that um, we set our API key. But right now we don't have an env file because we deployed it through through render, and you will just put your API key in the front end. Okay, so we're also getting our chain ID. We're using static method. If you don't really know what static method is, you can just copy all this and paste it, or copy it to Cascade and ask what is static method, and you get the answer. This is the era of vibe coding. You must not really need anyone to tell you everything about Python or any language that you need to learn. You can just on your AI, you can learn a lot. Okay, so we're using static method to get our API key to get the chain ID to execute the GraphQL query, and also to make requests. Okay, yeah. So our first tool, we're going to see it right now, and we'll be in a very big hurry because I don't want this video to be too long. I just need to be less than 30 minutes or so. So the first tool is our app transaction tool, and it's taking. Let me close this right here. We have our base model, and these are the schemas, the app ID, network, and limits. We also have the base tool. This is the official way of creating custom tool with CrewAI. So you have to define your base model, and you have to define your base tool. So the description of this tool is that it fetches transaction interacting with a specific protocol or the app or DApp, provides insights into how users are interacting with particular blockchain applications. Use this to monitor activity patterns on specific protocols. So this is just the description of the tool and what the tool does. And one important thing you have to see right here is that number one, um, we're using cache. We're using cache to make sure that we're not always using API credits whenever we run this tool. Okay, so if you don't really know what cache is, you can go to the CrewAI documentation. So I'm talking about this page, this create custom tool. You can see how they said which you can create a cache function. Yeah, so you can see it says to optimize tool performance with caching, define custom cache strategies using the cache function attributes. Okay, you can also see that you can also create your tool using base tool, or you can also use the tool decorator. But me, I do prefer the base tool. Yeah, so let's go back to our code. So we are back to our code, and right now, as you can see, we're using we are creating a GraphQL query for our transaction for app v2. If you go to the Zapper protocol documentation, you will know what the meaning of what transaction for app v2 means. So it's taking. We have to define the query. This is very very important. This really gave me a little bit trouble when creating this tool. So you have to define all this, and yeah, and other things like format app transactions and other functions that you have to define. Okay, so we are going to the portfolio tool. Let's see what this tool does. So we have our base model, which is the address and network, which are the schemas that we have to input, or it takes, or this is the schemas that this base model takes. And we also have our base tool, and description is fetches comprehensive portfolio data for a blockchain address, including token balances, DeFi positions, NFT holdings, and total portfolio value. Use this to analyze wallet holdings and assess portfolio composition. So this is just what this tool does. And like always, we also have our query, our GraphQL query. Yeah. So our next tool is the search tool. Let me close all this. Our next tool is the search tool, and these are the input schemas for the base model of this tool, and it takes query entity types, network, and limits as the input schemas. For the base tool, also takes description like performs a unified search across token, NFT apps, and accounts across multiple blockchain network. Use this to find specific entries when you have partial information. Support searching by name, symbol, or address fragments. Like always, we are using caching, and we are defining our GraphQL query. So the next tool is um, our token price tool, and for the input schemas, we have token address, network, days, and currency. For the base tool, we have the description which says fetches current and historical price data for a specific token using its contact address, provides price trend, market cap, and trading information, and trading volume information used to analyze token performance and market trend. Okay, and we're also using cache, and we're also defining our graph query. So the second to the last tool is called the transaction details tool, and what this does and the description of it that it fetches detailed information about a specific transaction, including metadata, asset transfer, and human readable description. Use this to deeply analyze individual transaction and understand complex DeFi operation. And for the input schemas, we have transaction hash and network for the input schemas of the base model. And our last tool is the transaction history tool. And for this, we have the base model and the base tool. For the base model, the input schema is address, network, and limits. For the description, it says fetches human readable transaction history for a blockchain address, providing simplified description of complex on-chain transaction used to analyze past activities and identify transaction patterns. So these are the 6 tools, if I'm not mistaken, that we have. And I designed or developed all this through the help of the Zapper protocol documentation. I'll leave the link in the description of this video. Please follow me and like. It really helps me a lot, to grow this channel. If you're enjoying my content, you can also share it with your friends so that we all can learn how to build AI agents with either CrewAI or LangGraph. Yeah, so for the code.py file, we have a lot of things going on. First of all, we are importing our libraries. We're importing agents, crew, process tags from CrewAI. We're importing the crew-based agents, crew attacks from CrewAI.projects. We're importing our load.env. We're importing our long-term memory. We're importing our LLM. We're importing LMC QS light storage. We're importing our paths. from CrewAI, but the part is from Patlib. Yeah, not from CrewAI. So we're also importing all our Zapper API tools. We are loading our environment variable for our API key. Yeah, so we are importing we're loading our environment variable for the API key. Um, yeah, so it's loading right now. Um, and we're also defining our LLM. Um, yeah, so for this project, we are using models from OpenRouter. OpenRouter is very good because it helps us to, pass the stage of, you know, getting errors, especially from LLM providers like Anthropic, getting rate limit errors, because on Anthropic and other LLM providers, you have to increase your deposit to, increase your tiers. There are different tiers with all these LLM providers, so you have to, there is tier one, tier two, tier three, tier four, and the higher you go, the higher your rate limit is, and the what is it called? The request per minute, the higher it is with each tier. So Open Router help us to pass those difficulties in getting higher rate limit and so. So with Open Router, you just have to put your API key, choose your model, and you're good to go. Okay, but you also have to be careful of the max tokens. For each LLM that you choose, you have to check um, the max tokens. You have to check the tokens for each, or the context for each LLM. Yeah, so right here we're defining our LLM. We have to LLM. I'm using Gemini 2.5 Flash and DeepSeek R1. Yeah, we're using temperature of 0.5 and a max token of 30,000 for DeepSeek and 50,000 for Gemini 2.5 Flash. Okay, if you want, you can just remove this and it will still work. But I just kept this so that I won't burn all my API credits. So we're defining our crew base. We're defining our class, which is Onchain Agent Crew. We are configuring. We are calling our agent and tax config, where we have the tax.yaml and agent.yaml file. We are setting up our directories for memories, where the memories will be stored and where the outputs will be stored. And we are calling our first agent the portfolio intelligence analyst, which is using LM2, it's using these three tools, which is portfolio tool, token price tool, and search tool. And we also have a rate per minute, max rate per minute, and max iter. Max rate per minute means how many requests. Oh, sorry, max request per minute, not rate. Request per minute means how many requests your agent get to make per minute. And max iter is how many times does a particular agent have to run to get the final answer for you. Okay, so if you have low API credits, you can reduce this to either 5. I don't know, but I just kept it. You can reduce this to any number that you want. But right now it's on 10. We also have another agent, which is a transaction pattern specialist, and it's using four tools right here, which is the transaction history tool, transaction detail tool, and app transaction tool, and also the search tool. We have the cross chain investment strategists, and you can see the two tools it's using. And we have so those are the three agents. Right now we are going to the tax. We're going to the tax. We have the first tax we have is the portfolio analysis tax. You can see how we defined it using the tax decorator. We have the transaction pattern analysis tax. We have the investment opportunity identification tax, and we have the comprehensive intelligence report tax. And we are defining our crew for the agents. We are calling the self.agent, and for the tax we are We are calling the self.tax, and we are using sequential process. Just to keep it simple, we're using repose as true, and we're using long-term memory. You don't really need memory for this agent, but me, I just like adding memory whether my AI agent needs it or not. I don't know how this improves the performance of your AI agent, but I just always define the memory whenever I'm building an AI agent with CrewAI. So the main.py file, um, like you saw, like if I don't know if you noticed in our tags.yaml file, we have different inputs that we left. Yeah, we left the wallet address, and also what else again? Also the network too. I've forgotten what this is called. Pardon me. But all this in curly brackets, you have to define it as an input in the main.py file, which we are going to do right now. Okay, so in the main.py file, you can see the inputs. You can use your own wallet address. For me, I went to Etherscan and I got this wallet address, not for me. And for the network, I put Ethereum, Polygon, and Base. Okay, so we're not going to use this main.py file because, like I said, we created a UI with Streamlits, and we are going to see how we created it. Okay, so for the output handler, we have the output handler.py file. First of all, we have the requirement.txt. We have Streamlits, CrewAI, Python.env, and requests. You can do pip. You can install this with pip, or you can install this with UV if you want. I did install it with pip, okay, because UV, UV and Streamlits, they don't really work. I don't really know how to do it, but just to make it faster, I used pip to install everything in the requirement.txt file. Okay, right here we have the output handler. Right here we are importing Streamlit as ht. I don't really know why we need it right here, but we didn't use this. My apologies. So right now we are importing SYS, and this provides access to the Python interpreter variable and function. We're also importing context manager from context lib, and this is a decorator for creating usable context manager. We're importing string IO, and this creates in-memory text stream for capturing outputs. And we're importing RE, which is a Python regular expression model for pattern matching. Yeah, so this first set of codes, this takes a Streamlit container as input, where the output will be displayed and track the complete output text. It also keeps track of lines already displayed to avoid duplicates using a set. And this clean text function, remove ANSI escape codes, especially characters used for terminal formatting like colors, and also this also further cleans specific format code to ensure clean text outputs in Streamlit. I'm talking about this clean text function. So all these codes are just codes for we can call it a preprocess code for helping us to format our outputs and make our outputs much readable. Also, the context manager, it helps, or this allows this takes a Streamlit container. I'm talking about this lines of code. This takes a Streamlit container as inputs. It creates a Streamlit process output handler connected to that container, and this temporarily redirects the Streamlit standard output SYS sys to this handler. It also yields control back to the calling code, and when the contents manager exists, it restores the original standard outputs. Okay, yeah. So this is what the contents manager does. Yeah, so we are in the agent bridge.py, and this helps us in you know calling our crew, which is the um, online or the on-chain agent crew, and before we and it also passes it to the app.py, also passes to the app.py file. So let's see how it's been created or how I created it. We're importing our on-chain agent crew. We're importing capture output from output handler, which we saw over here. We're also importing str streamlit and pathlib or we're importing path from pathlib. So we have this function right here, this run on chain analysis. This takes wallet address, network, and output container, and it returns the result of the analysis. We also have the inputs right here, the wallet address. We have the network. We have we're also creating an output directory for our memory and output. This is not really needed, but I still did it. And we are initializing our crew, and you can run with or without output capturing. So this is not really needed right here. And we also have another function which is get report contents, and this reads the generated reports contents from the output file, and it returns the report content as a string or none if no report was found. We have some error handling code over here. So we're in our app.py file, and we are adding the absolute paths to the on-chain directory, and we are importing our on-chain agent crew after the path sets, which is this path right here, and we are loading our .env variables, and we are also configuring the page. Okay, so we're setting the title of the page. We are initializing the section states variable, or you put the API key, and we are defining the main header, and we are creating the sidebar for the API keys. So this is where you put the Zapper API key and the Open Router API key. For the Open Router API key, let's go and see how we can get our API key. Yeah, so for your API key, all you have to do is go to openrouter.ai. You hover over your picture and you click on credits. This is where to add credits. It will take you to this page, and you just click on add credits, and you add the credit that you want. And once you've bought some API credits, go to API keys right here, and you click on create, and you create your API key. Make sure you copy it because you can only see it once. And yeah, that's how to create your API key. Yeah, so that's how to get your API key, your Open Router key, or your API key for your Open Router or from Open Router. This code is just to create an environment variable and to tell you that your API key is set successfully once you put your Zapper and Open Router API key. So this is just the about section on the sidebar. Yeah, with my details and everything, and we're setting the first column and the second column. And on the first column, we have the wallet address, which you have to put your wallet address. And on the second column, you choose any network that you need or that you want, and these are the default network. And yeah, this is the run analysis button, which you press and it would run the AI agents. And this is to check if the API key is set before running. And if it's not set, I think it will give you an error which you say please set your API key in the sidebar first. And we're also creating an output directory right here, and our output and memory folder to store our output and memory. And with this, it's run the analysis, or it's run the AI agents, and this will initialize and run the crew, which is the on-chain agents. And we're also seeing our crew.kickoff code right here, which takes the inputs that you set in Streamlit. And when the AI agent is complete or finished running, it will tell you analyze complete or analysis complete state, and it will give you the state complete. And this is an error handling code to handle any error that comes up. And it will display your results. It will display your results. We run it right now, and we'll see how it works. And you can also download the results, which will come in a markdown file. So let's see how we can run this right now. So I'll open my terminal. And I'll cd into Streamlit. Then with that, we do Streamlit run app.py. Okay, it gave me an error. Okay, right now I noticed why we got the error. I didn't create my virtual environment and activate it, but right now I've created it, and we are going to activate it right now. So it's activated, and we are going to run the Streamlit app right now. Streamlit run app.py, because our Streamlit code is in app.py. So let's go. And let's go to our Streamlit app. So our Streamlit app is up and running right now. As you can see the section for the Zapper API2. You can see the section for the OpenAI key, and also you can see the about section with my contact and everything. So this is where you put the Ethereum wallet or any crypto wallet address, and you can choose any other cryptocurrency that you want to choose, and you run it. So let me get my API key and my wallet address. Yeah, so right now I've gotten my Zapper API key and OpenRouter API key. I also input a random, I think this is an Ethereum wallet address, and we'll click on run analysis. Let's just do only for Polygon and Ethereum, and run analysis. So right now it's running, so I'll pause the video and come back after it's finished running. So as you can see, we have our results right here from the Onchain AI agent that we ran. We have a comprehensive intelligence reports for this product address, and they give us the executive summary, the integrated performance analysis, the behavioral profile and strategy assessments, relationship and influence map, integrated risk assessment, and the strategic action plan. Yeah, so you can run this and see the results, but before you run it, you have to use a wallet address that has a good amount of crypto in it and a good amount of transaction history. Yeah, so if you have any question, let me know. And if you're enjoying this, and please subscribe to my YouTube channel and leave a like. Also leave a star on the GitHub repo, which will be in the description of this video. Yeah, so let's see how we can deploy this through render. So to deploy this through render, you just have to push your code to a GitHub repo. I hope we all know how to do that. So you just have to push this to a GitHub repo. As you can see, I've done mine. We have the folder for the Onchain AI Agents where we put all the CrewAI codes, and we also have another folder for the UI that we made with Streamlit. Yeah, so once we've done that, then you have to go to render. We can go to render.com, sign up, I think it will take you to a page like this, or you can also click on projects and it takes you to a page like this. Then you click on new, then click on web service, then you click on GitHub provider. Also, if you are signing up, please sign up with your GitHub credentials, because if you don't sign up your GitHub with credentials, then you have to still connect your GitHub profile with render. So signing up with your GitHub credentials is much easier if you want to deploy any code on render. Yeah, so when you click here, you see search. It will show you your latest project that you have on GitHub. You can see we have the Onchain AI Agents project. You click on it, then you put the name, you put a unique name, and you put Python 3, of course we're using Python. Then you click on main, because it's the main branch. As you can see right here, we're using the main branch. Then you leave this as it is. Then you root directory where the directory where the Streamlit code is. For our own, it's in the Streamlit folder or directory. Then you copy it, you come here and you paste it right here. Yeah, Streamlit. And to install the dependencies or the libraries, it will surely use pip install R requirement to install all the dependency and libraries in the requirement.txt file. And to run your code, then you have to use like always Streamlit run app.py. Then you have to choose the free version, and no need to put any variable or add any .env file for your API key, because we will put our API key on the front end. Yeah, so with that, you just click on deploy web service, and I don't want to click on it because I've deployed the one for our Onchain AI agent. And when you deploy it, it take like from 2 to 5 minutes, and to show you the link to go to. So let's see my own, the one I deployed. We'll go back to workspace. If give me a minute. Yeah, so this is my products, and this is the on-chain I deployed. Then you just copy the link. As you can see, it will show you all the logs, to show you all the logs and everything. And when you finish deploying, to give you a link, you copy it and you open a new tab, place the link and hit enter, and it will take you to the link. So you can give this link to anyone, and it will be available 24/7. Okay, but for the free version of in render, if you haven't visited this link for a very long time, if you want to visit again, it will take some time, or it takes some minutes before it loads. It might take from 2 to 5 minutes before it loads. Okay, that's if you haven't visited this link for a very long time. Yeah, so that's all. Please give me a like and a follow, and or subscribe to my YouTube channel, and I would be very glad if you do. Thank you very much. See you when I release the other tutorial about AI agents.